Alright, so in this example problem we have a Velcro ball that is being thrown with a velocity of 10 meters per second. So we're going to have a ball here, and it's going to have an initial velocity of 10 meters per second. And we know it has a mass. We're going to call this object 1. Has a mass of 0.3 kilograms. And that ball is going to hit a target on wheels that's initially at rest. So we're going to draw a target here, and this target has some wheels at the bottom of it. And it has a mass of 10 kilograms, so we'll make that object 2. And its initial velocity is equal to 0. The objects are then going to collide, and they're going to stick together. And we don't know which way they're going to move because that depends upon the conservation of momentum. So let's consult our numbers and figure out which way this target ball system is going to move together. So since they stick together after the collision, that is going to be a perfectly inelastic collision. So I'm going to first plug in my initial conditions here. So I'm going to take the mass of the Velcro ball times its initial velocity. So we're going to take 0.3 times 10 plus the mass of the target times its initial velocity. So we're going to take 10 times 0, and that's going to give us 0. So initially we have 3 kilogram meter per second of momentum. Then we're going to plug in our final conditions, recognizing the fact that the final velocity of both objects is going to be the same because they've stuck together. So we have mass 1 plus mass 2. That's going to give us 10.3. And we carry through our unknown, the velocity final. So we're going to take 3 divided by 10.3 in order to get 0.29 meters per second. So after the collision, the object is going to have a small velocity in the positive x direction. And we expect it to be relatively small because while this ball has a decent initial velocity, its mass is much, much lower than the mass of the target. So you're taking 3 kilogram meters per second that used to belong to just a 0.3 kilogram ball, and you're spreading it over now 10.3 kilograms of mass. So you're going to end up with a smaller velocity in order to have the momentum be conserved.